Good day. I am Mr. Bryan Lazaro, and I will be your mathematics teacher for today. Our discussion will focus on the equation of a circle. But before that, you need to help me first in order to solve a crossword puzzle. And the topic for the crossword puzzle will revolve around our previous topic. Alright, let's answer some questions. First question. It is the distance between any 2 points on the circumference of the circle. Do you know the answer? Very good. It is arc. Arc is the distance between any 2 points on the circumference of the circle. How about number 2? The distance around the circle. Very good. It is circumference. Alright. Let's have number 3. The distance from the center of the circle to a point on the circle. Very good. It is radius. Okay. How about number 4? The line segment that joins any 2 points in the circle and passes through its center. Very good. It is diameter. Alright. How about number 5? It is a closed curve in a plane. Very good. It is circle. Okay. How about number 6? All points in the circle are equidistant from this point. This is a very important part of a circle. Alright, very good. It is the center. Center is all points on the circle are equidistant from this point. Okay, very good. How about number 7? Very good. It is chord. Alright. So let's have a quick recap of the parts of the circle. We now have the main parts of the circle. The first part, the center. The second is the chord. Third is the diameter. Fourth is our radius. Fifth is the arc. And seventh is the tangent line. All of these are important parts of a circle. And in real-life application, we always see circles, like for example a steering wheel on a car, the clock, the wheels in our bicycles, and of course, the Ferris wheel in an amusement park. We already know that these are applications of circles, but there's one question that we need to answer. And what is that? How did every professional or creator of circular things consider the distance of every point in a circle? We already tackled a while ago and reviewed that center is equidistant from any point on the circle. Therefore, it is very crucial for a professional to measure the distance of every point in the circle to provide balance. And how do they compute it? That will be our lesson for today. Let us first define what a circle is. A circle is the set of points in a plane that are equidistant from the center. It is the set of points in a plane, and all of these points are equidistant from the center. If we're going to draw it, let's say for example we have a center HK and a radius R, and every line, every point is equidistant from the center. We could draw it like this, representing it as XY. We can now draw a circle. Okay. Remember that the radius R is the distance between the center, or the HK, and any point which is represented by XY on the circle. Alright. Let us now have the circle equation. How are we going to compute or find the equation of a circle? Very good. We are going to use the distance formula. And what is the distance formula? The distance formula looks like this. R is equal to square root of x minus h squared plus y minus k squared. From this, we're going to derive the equation of a circle. Okay? First, you need to square both sides. Why do we need to square both sides? It is in order for us to eliminate the radical sign. So since we took the square of both sides, we can now have this equation. R squared is equal to x minus h squared plus y minus k squared. Okay, that will be our equation of the circle, where hk is our center. Remember that. hk is the center from this equation. And we have r as our radius. And of course, xy, which is any point on the plane, on the circle I mean. Okay, now let us have some examples and application of these concepts. Let's start from the easiest. What is the center and the radius of the given equation? From here, we're just going to take x minus 9 first in order to find our h. Okay? So we have now x minus 9 equated to 0 so that it will be very easy for you to find what is our h. X is equal to transpose negative 9 to the other part of the equation. That will be x is equal to 9. So our h now is equal to 9. Okay. And then, let's proceed to our y minus 1. Okay. Our y minus 1 will be equated also to 0. Why? Okay, so we have y minus 1 is equal to 0. Transpose negative 1 to the other side of the equation. That will be y is equal to positive 1. Therefore, our k is equal to 1. So we have now our h, and we have our k also. So what's next? We're going to find our radius. In order to find radius, we need to obey the rule. We need to put it in our equation. Our equation is x minus h squared plus y minus k squared is equal to r squared, and r squared is our radius. So we have now r squared is equal to 25. Then, in order to eliminate that square, or the power of 2, we're just going to take the square root of both sides. Take the square root, then r is equal to 5. Alright. Therefore, we already have now our center. Our center will be 9, 1, and our radius is equal to 5. Okay. Did you get it? Very good. Let's proceed to our second example. How about this problem? Write the equation of a circle with center 5, 6, and radius 4. What are we going to do first? Of course, we need to write the circle equation first. This will serve as our guide in the whole process. Okay, 5, 6 is the center. Therefore, that is our h and k. We're just going to plug it in. Plug 5 for h and plug 6 for k. Okay, and our radius Again, we're just going to plug it in. And rewriting this whole equation, we're going to have 4 squared is equal to x minus 5 squared plus y minus 6 squared. And we're going to simplify our radius. Our radius will be 4 squared is equal to 16. And our final equation will be x minus 5 squared plus y minus 6 squared is equal to 16. Did you get it? Very good. Next example. Write the equation of a circle with center 1, negative 3, and radius 8. We're just going to repeat the same method we did from the previous example. Okay. What's the first thing? Write the equation. Okay, or the general equation of the circle. After that, plug in the necessary data. Our h, 1, our k, it's negative 3, and our 8 is our r. Okay, resulting to 8 squared is equal to x minus 1 squared plus y minus negative 3 squared. Then simplify it. Therefore, our answer will be, and the equation of the circle will be, x minus 1 squared plus y plus 3 squared is equal to 64. Okay, very good. Now, let's answer this problem given all the things that you've learned. Is the point 34 on the circle in its exterior or in the exterior? Given the equation x plus 1 squared plus 1 minus 1 squared is equal to 25. When you say on the circle, the point lies on the line of the circle. When you say in its exterior, it lies inside the circle. When it is exterior, the point lies outside the circle. So first, we need to graph the given equation. Okay, graph it. The center is negative 1, positive 1. There you go. And our radius is of length 5. Then let us draw it. Okay. From then, let us locate 3, 4. Where is 3, 4? There you go. There's 3, 4. Therefore, we can now answer the question. It is on the circle because it lies on the outline or the line of the circle or the circumference of the circle. Now, what you can now do after all the things that we've discussed and you've answered. 1, you can now write the equation of a circle. You can now graph a circle from its equation. And also, you can determine where a point is in the interior, exterior, or on a circle. And for that, I congratulate you. Okay, for your homework, you're just going to click the link below that I've provided. For those people who've downloaded the application I gave to you, you can answer it through that application. For the people who wants to use the module, you can click the link below so that you can retrieve the module that I have made for you. Alright, I hope you learned many things today, and I hope that everything that I've imparted to you, you will remember it and you will apply it to the real world. Now we can now answer our question a while ago. Professionals and other creators of circular things measures the distance through the equation of a circle in order for them to provide balance and equality within the circle. It is very important for a circular thing to be balanced because by definition itself, circles have centers that are equidistant with any point on the circle, which are actually having the same length for all radii. Okay, thank you for listening today. Again, I am Mr. Bryan Luis G. Lazaro, And I am your mathematics teacher.